Welcome to ChemExamPrep.com. We are now in the part of the training for that countdown. We're on, number 6 in the countdown, and we had described the issue potentially being two things. One, not knowing nomenclature. So let's really focus on nomenclature because it's just paramount to your understanding of chemistry to understand how to identify and how to describe molecules, by their names. In the case of carbon dioxide, it's a binary covalent compound, and you'll be able to recognize it by, using these Greek terms, these prefixes, mono, di, tri, and of course it's two nonmetals. So carbon monoxide, diphosphorus decoxide, and you can see with binary covalent compounds, you use the prefix in both the first as well as the second term, except in the case of if it's just a single. So in the case of carbon monoxide, you don't say monocarbon monoxide. You just say carbon monoxide, but that's one carbon, one oxygen. So that's nomenclature of binary covalent compounds. So you're going to get used to the mono, di, tri, etc. Hexa, you can go on. Now, what are the rules? Obviously the one thing is when we're talking about binary covalent, it's not an ionic bond, it's a covalent bond. And it's nonmetals to nonmetals. So with terms of naming, in these type of compounds, you just write the first element's name with the prefix indicating the number of atoms. Obviously in the case of 1, you don't have a prefix. And then you write the second element's name with the prefix indicating the number of atoms and then the suffix "-ide". And this is the rule here. The prefix mono is not used on the first element. So that, in a nutshell, is the nomenclature. Now let's see if it wasn't nomenclature, it was just setting up the dimensional analysis. I wanted to go through basic understanding of if you're trying to convert grams to molecules, how do you go from grams to molecules? The key is to use moles. So if you can convert grams to moles, and then you can convert moles to molecules using Avogadro's number, you can then, in essence, go from grams to molecules to convert and identify how many molecules you have. In this case, sodium chloride. And then in the case of sodium chloride, you can also say that there are 2.63 times 10 to the 23rd sodium atoms in sodium chloride. So you can look at the stoichiometry and determine the answer. So this is given as a training to help understand, the bigger problem which we had discussed. I'm just going to bring it up real quick. We take a look at the missed question, and you're given 52.6 grams of carbon dioxide, and you have to go to carbon atoms. So you're starting at grams of carbon dioxide, getting that to moles of carbon dioxide, switching that to moles of carbon, and then switching that to atoms. All right, so that is the end of the training session, and I would recommend that you keep practicing that. Now let's go find some example problems for you. Thanks. Bye.